We'll talk in this presentation about quality control test of oral liquid preparations. Contents of the presentation. 1. Introduction. 2. Universal tests for pharmaceutical oral liquid preparations, which includes description, identification, assay, impurities. 3. Quality control test for liquid dosage. Forms, it has two ways. 1. Official. 2. Unofficial, like emulsion and suspensions. First point, introduction. The pharmaceutical oral liquid preparations accounts for approximately 20% of all dosage forms on the market. For that, quality control tests for liquid dosage forms are important for several reasons. First, safety, to ensure the safety and quality of medications. Second, efficacy, determining the content of active substances in liquid dosage forms. These tests ensure the accurate dosage and efficacy of medications. Third, uniformity, to ensure that each administered dose contains the specified amount of active ingredient. Fourth, stability, assess the product's stability under various storage conditions to ensure its effectiveness over its intended shelf life. And here is the classification of oral liquid preparations. Second point, types of liquid dosage, form tests. Universal tests for pharmaceutical oral liquid preparations. First, description. This test is often called appearance on a specification and is a qualitative description of the pharmaceutical oral liquid preparations. For example, the description of a syrup on a specification may read, red color, slight characteristic odor, mild taste. Second, identification. The purpose of an identification or identity test is to verify the identity of the API in the pharmaceutical oral liquid preparations. This test should be able to discriminate between compounds of closely related structure that are likely to be present. Third, impurities. This test determines the presence of any component that is not the API or an excipient of pharmaceutical oral liquid preparations. The most common type of impurities that are measured is related substances, which are process impurities from the new drug substance synthesis, degradation products of the API, or both. Fourth, assay. This test determines the strength or content of the API in the pharmaceutical oral liquid preparations and is sometimes called a content test. Third point, the second type of liquid dosage form tests. Quality control tests for liquids dosage forms. First, official tests for liquids dosage forms. 1. Uniformity of mass of delivered doses. Used in liquid preparations for oral use, supplied in multi-dose containers, except oral drops. Method, weigh individually 20 doses, units taken at random from one or more containers, with the measuring device provided, and determine the individual and average masses. As stated by BP, not more than 2 of the individual masses deviate from the average mass by more than 10% and non deviates by more than 20%. 2. Viscosity. Viscosity is a property of liquid that is closely related to the resistance to flow. It is defined in terms of the force required to move one plane surface continuously past another under specified steady-state conditions when the space between is filled by the liquid in question. 3. Potential of hydrogen. pH of the oral liquid preparations must be optimum as they are administered. The pH value conventionally represents the acidity or alkalinity of an aqueous solution. In the Pharmacopoeia, standards and limits of pH have been provided for those pharmacopoeia substances in which pH, as a measure of the hydrogen ion activity, is important from the standpoint of stability or physiological suitability. Measurement. 4. Uniformity of content. According to BP, this test is applicable for single-dose preparations that are suspensions. This test is also applicable for single-dose powders and granules for syrups, oral solutions, oral suspensions, and single-dose powders for oral drops with a content of active substance less than 2 mg or less than 2% of the total mass, except single-dose preparations that are suspensions. If the preparation has more than one active substance, the requirement applies only to those substances that correspond to the above conditions. According to IP, unless otherwise specified, single-dose liquids in suspension form or powders or granules presented in single-dose containers and that contain less than 10 mg or less than 10% of active ingredient also comply with this test. Calculate the acceptance value using the following formula: mx plus ks, where m reference value, x mean of individual content, x1, x2, xn expressed as percentage of the label claim, k TRF acceptability constant. 5. Uniformity of mass. According to BP, this test is applicable for single-dose preparations that are solutions or emulsions, single-dose powders and granules for syrups, oral solutions, oral suspensions, and single-dose powders for oral drops. For this test, weigh individually the contents of 20 dosage units taken at random, emptied as completely as possible, and determine the average mass. As stated by BP, for single-dose preparations that are solutions or emulsions, not more than 2 of the individual masses deviate by more than 10% from the average mass, and none deviate by more than 20%. For single-dose powders and granules for syrups, oral solutions, oral suspensions, and single-dose powders for oral drops, according to BP, not more than 2 of the individual masses deviate from the average mass by more than the percentage deviation shown in table, and none deviates by more than twice that percentage. 6. Mass variation. According to BP, accurately weigh the amount of liquid that is removed from each of 10 individual containers in conditions of normal use. If necessary, compute the equivalent volume after determining the density. Calculate the active substance content in each container from the mass of product removed from the individual containers and the result of the assay. Calculate the acceptance value using the following formula: etim m x sal plus kssc equals sign yxaw. 7. Uniformity of volume. This test is suitable for oral liquids and oral suspensions of viscous preparations. For this test, select a sample of 10 filled containers and determine the weight of the contents of each container. Determine the weight per milliliter and calculate the net volume of the contents of each container. For non-viscous and free-flowing liquids, pour completely the contents of each container into calibrated volume measures of the appropriate size and determine the net volume of the contents of the 10 containers. Consistent with IP, the average net volume of the contents of the 10 containers is not less than the labeled amount, and the net volume of the contents. If this requirement is not met, determine the net volume of the contents of 10 additional containers. The average net volume of the contents of the 20 containers is not less than the labeled amount, and the net volume of the contents of not more than one of the 20 containers is less than 91% or more than 109% of the labeled amount, where the labeled amount is 50 milliliter or less than 95.5%, or more than 104.5% of the labeled amount, where the labeled amount is more than 50 milliliter, but not more than 200 milliliter, or less than 97%, or more than 103% of the labeled amount, where the labeled amount is more than 200 milliliters, but not more than 300 milliliter. Eight, uniformity of weight. This test is suitable for powders for oral liquids. For this test, select a sample of 10 filled containers and remove any labeling that might be altered in weight while removing the contents of the containers. Clean and dry the outer surfaces of the containers and weigh each container. Remove quantitatively the contents from each container. If necessary, cut open the container and wash each empty container with a suitable solvent, taking care to ensure that the closure and other parts of the container are retained. Dry and again weigh each empty container together with its parts which may have been removed. The difference between the two weights is the net weight of the contents of the container. As per IP, the average net weight of the contents of the 10 containers is not less than the labeled amount and the net weight of the contents. If this requirement is not met, determine the net weight of the contents of 10 additional containers. The average net weight of the contents of the 20 containers is not less than the labeled amount, and the net weight of the contents of not more than one of the 20 containers is less than 91% or more than 109% of the labeled amount, where the labeled amount is 50 gram, or less than 95%, or more than 104.5% of the labeled amount is more than 50 gram, but not more than 100 gram. 9. Dose and uniformity of dose. This test is applicable for oral drops. For this test, into a suitable graduated cylinder, introduce by means of the dropping device the number of drops usually prescribed for one dose, or introduce by means of the measuring device the usually prescribed quantity. The dropping speed does not exceed 2 drops per second. Weigh the liquid, repeat the addition, weigh again, and carry on repeating the addition and weighing until a total of 10 masses are obtained. Following BP, no single mass deviates by more than 10% from the average mass. The total of 10 masses does not differ by more than 15% from the nominal mass of 10 doses. If necessary, measure the total volume of 10 doses. The volume does not differ by more than 15% from the nominal volume of 10 doses. Second, unofficial tests. First type, emulsion. First type of emulsion, visual inspection. In case of oral emulsion and oral drops that are emulsions, evidence of physical instability is demonstrated by phase separation that is not readily reversed on gentle shaking. Second type of emulsion, droplet size. This test is applicable for pharmaceutical emulsion. Growth in the droplet size after the preparation of an emulsion is an indication of its physical instability. Third type of emulsion, thermal stress. Measurement. It is usual to evaluate the stability of an emulsion by subjecting it to high and low temperatures in alternating cycles. The samples are first exposed to 60 degrees Celsius for a few hours and then to 40 degrees Celsius. Such exposures are repeated a number of times and emulsion stability assessed after each cycle. Second type, suspensions. First type of suspensions, visual inspection. Evidence of physical instability of oral suspension and oral drops that are suspensions is demonstrated by the formation of flocculants or sediments that do not readily disperse on gentle shaking. Second type of suspensions, redispersibility. If a pharmaceutical suspension produces sediment upon storage, it is essential that it should be readily dispersible, so that uniformity of dose is assured. The amount of shaking required to achieve this end should be minimal. Third type of suspensions, zeta potential. It can be determined by observing the movement of droplets under the influence of an electric current, electrophoretic mobility measurements, often in conjunction with photon correlation spectroscopy.